In this lesson, we will talk about the unit circle. The goals of this lesson are to identify the position of all radian values on the unit circle, understand the conversions between radian and degree values, and finally to find wrapping values. When we talk about the unit circle, we are talking about a circle that has a radius of 1. So we remember that the radius is the distance from the center to the outside, any outside point on the circle. To calculate the circumference then of the unit circle, we use the formula 2 times pi times the radius. Since we know that the radius is 1, that means that we would be calculating 2 times pi times 1. Now from there, that means that our circumference is 2 pi. So therefore, the distance all the way around the unit circle is 2 pi. So the next thing we're going to talk about is how to find the radian measures. Now we are going to start over on the right side of the unit circle in this position here. And that is going to be at 0. Now as we wrap all the way around the unit circle, we would then arrive back in the same location, and since that distance all the way around is 2 pi, we would be at 2 pi in that position. So if it's 2 pi all the way around, then when we get halfway around the unit circle, we will be at pi. And again, bringing us back to 2 pi right here. So now in the middle, between 0 and pi, we are going to be at half of pi, and we will write that as pi over 2. If I continued traveling around, I'd start at 0, I'd then be at pi over 2, then I'm at 1 pi, and then I would be at 1.5 pi. We could also think of that as 3 halves pi, or for our purposes, we're going to say 3 pi over 2. And then again, we would be back at 2 pi. From there, we break each quadrant in half. Now what happens here is if we take half of pi over 2, we would be at pi over 4. Now if I am breaking these all up into fourths, if you think about it, if I'm starting here at 0, this is going to be 1 pi over 4. This position would then be 2 pi over 4, and that would reduce to pi over 2. The next position then is going to be 3 pi over 4. From there, we would be at 4 pi over 4, which we would then reduce to pi. Then we would be at 5 pi over 4. The next position would be 6 pi over 4, which again we could reduce to 3 pi over 2. Then we would be at 7 pi over 4. And then finally, back in this position, we would be at 8 pi over 4, which reduces to 2 pi. So from there, we're going to establish some guidelines. And this is kind of like a trick for remembering when we do add in a couple more values in the first quadrant, second quadrant, third, and fourth quadrants, we want to have some rules for their numerators. So in the first quadrant, the numerator is always going to be 1 pi. In quadrant 2, the rule that we're going to follow is that the numerator will be 1 less than the denominator. In quadrant 3, the numerator is going to be 1 more than the denominator. And then finally in quadrant 4, the numerator is 1 less than twice the denominator. So if I take 4 and multiply that by 2, I'd get 8. 1 smaller than that would give me 7. Now from there, we're going to break it down a little differently. Next, what we'll do is we'll break it down into sixths. So when I start here again at 0, my first value here is going to be pi over 6. Now when I move to my next position, I would be at 2 pi over 6. Well, 2 pi over 6 actually reduces to pi over 3. Now I can keep going. Over here, I would be at 3 pi over 6, which again is going to reduce to pi over 2. My next position would be 4 pi over 6, which again would be improper, so we would reduce that to 2 pi over 3. If I keep going over here, I would now be at 5 pi over 6. And you can see that the rules so far are holding up. Both of these have a numerator of 1 pi. Both of the values in quadrant 2 have numerators that are 1 less than the denominator. When we move on, I would now be at 6 pi over 6, which reduces to pi. My next value would then be 7 pi over 6. After that, I would be at 8 pi over 6, which reduces to 4 pi over 3. And we can see that these numerators are one more than the denominator. Then, of course, when we get here, we'd be at 9 pi over 6, which we would reduce. My next one would be 10 pi over 6, which we would reduce to 5 pi over 3. And then my next one is 11 pi over 6. And then finally, when we come back up here, we would then be at 12 pi over 6, which reduces to 2 pi. Now from here, you can see that quadrant 4 continued to follow that rule where if we multiply the denominator by 2 and then subtract 1, we would get 5. Here, the same thing happens. 6 times 2 would give us 12, take away 1, and we're at 11. Now I've just put back in the denominators of 4, so the unit circle is complete. These are the values that we will be memorizing for everything else in this unit. Once again, you can see that in quadrant 1, all the numerators are 1 pi. In quadrant 2, we are looking at the fact that all of these numerators are 1 smaller than the denominator. In quadrant 3, we're looking at these values here. All of those numerators are 1 more than the denominator. And finally, in quadrant 4, all of these numerators are 1 less than twice the denominator. Some examples. The way that your questions will look when we're talking about wrapping values would be like this. The W standing for the wrapping value of pi over 2. So because pi over 2 is at the top of the unit circle, since the position there is 0, 1, its wrapping value is 0, 1. For number 2, if we're talking about pi, pi is in this position over here. So the associated wrapping value of pi would be negative 1, 0. In question number 3, we're asking about 3 pi over 2. So again, we have to know the position of 3 pi over 2 is at the bottom of the unit circle, and then the associated wrapping value would be 0, negative 1. And then finally, for number 4, the wrapping value of 0, we are going to be in this position over here, and that's going to be 1, 0. Moving on. So we need to talk a little bit about degree and radian conversions. Now you're not going to complete any problems exactly on converting back and forth between degree and radian, but I do want you to understand where these are coming from. If you are trying to move from degree mode into radian, what you would do is take the degree measure, you would multiply that by pi over 180, and that's going to give you the radian measure. So for example, if you took a 30-degree angle and you wanted to change that to make it a radian measurement, we would multiply by pi over 180. Now, 30 and 180, that part right there can simplify. So I rewrote this as 30 over 180 times pi. Nothing's canceling that pi out. So from here, when we reduce 30 divided by 180, we get 1 over 6. So if I get 1 over 6 times pi, I'm going to get pi over 6. So 30 degrees is equivalent to pi over 6. Now going the opposite direction, if you have a radian measurement and you're trying to find its degree measurement, we take that radian measurement, we multiply by 180 over pi, and that's going to give us the degree measure. So for example, if I took 5 pi over 4 and I wanted to change that into degrees, I would multiply that by 180 over pi. Now what's going to happen here is that our pi's will cancel. And if you think about it, radians should have the pi value in it. Degree measurements wouldn't. So we want to get rid of the pi. So if you're ever getting confused between where the pi should belong, think about whether you're trying to incorporate it, which would be going into radian, or if you're trying to get rid of it, going into degrees, then we want them to cancel like this. So now I'm left with 5/4 times 180. Which then can reduce the 180 over 4 part. We end up getting 5 times 45, and that gives me 225 degrees. Again, something I want you to understand, but not something that you're going to actually have to complete problems on. But because of this, we can talk about 3 specific angle measurements here. 30-degree angles, which are going to convert to pi over 6 as a radian value. 45-degree angles, which its radian value would end up being pi over 4. And then finally 60-degree angles, which if you did the conversion there, you would get pi over 3 for its radian value. So we want to understand the associations here. And that brings us to the next part. Now when we're trying to come up with the ordered pairs that are associated for each of these different positions, we have to look at some special right triangles. Now you've seen the ratios for special right triangles in geometry before, but we're going to go through this. Again, something that I want you to understand. I don't want you to think I just came up with these out of nowhere. I want you to see where they come from, but you won't actually have to show me the calculations for this. So in a 30, 60, 90 triangle, the ratio is x root 3, and 2x. Now what we know in this is that across from this 90-degree angle is the hypotenuse right here. And so that's going to be, since we know that this is the radius measurement, that 1, we can plug that in here. Now that helps us to figure out what x is, because we know that if 2x is equal to 1, then we can figure out x. Therefore, x would be 1/2. Now that is going to go up in the top part of our box here, and it would go across from the 30-degree angle. We could also plug in x as 1/2 here. That's going to give me 1/2 root 3, which ends up being root 3 over 2. So again, the 1/2 goes in this position over here because it's across from the 30. And then the root 3 over 2 would end up being here because that's across from the 60-degree. Now, when we're looking for the ordered pair here, we would travel along the x-axis and then along the y-axis. So since the distance for the x-axis here is root 3 over 2, and the distance for the y-axis here is 1/2, the ordered pair that we will use every time we're dealing with a denominator of 6 is going to be root 3 over 2 comma 1/2. And we'll talk about some different signs for these later. Now in our next triangle, it's a 45, 45, 90. We know that if this is 45, this would also have to be a 45-degree angle to make it this special right triangle. The ratio here is x for 45 and x root 2 for 90. Once again, we know that the radius is 1. We have that measurement. So I can plug that in. Since it's across from the 90-degree angle, I can plug that in here. So if I set x root 2 equal to 1 and solve that, what ends up happening here, we divide both sides by root 2. Now I get 1 over root 2, and I need to rationalize that. So to do that, we would multiply top and bottom by root 2. Now here we end up getting root 2 over the square root of 4, but then the square root of 4 right here would then turn into 2. So we get root 2 over 2. Now we would plug that in across from the 45-degree angle, which again, since both of these angles are 45, both of these sides end up being root 2 over 2. So finally, when we talk about the ordered pair here, it's the distance this way on the x-axis, which is root 2 over 2. Then it's going to be our distance up along the y-axis, which is again root 2 over 2, meaning that we end up with an ordered pair of root 2 over 2, root 2 over 2. And finally, we have another 30, 60, 90-degree triangle. Even though this triangle that we looked at initially and this one right here, they don't necessarily look the same, but if we're talking about angle measurements here, the 60-degree angle is right here at the origin, while now the 30-degree angle is here. So it's the same triangle measurements that we're going to get here, it's just that they're arranged in a different order. So here we do the same thing we did in the first example. We take 2x and set it equal to 1, and we solve that. We get 1/2. So again, since that's x, I'm going to plug that in to the top box there. Then I can take that 1/2, since I know that that's the value for x now, and I can plug in 1/2 root 3. 1/2 root 3, another way to write that would be root 3 over 2. And just like we've done on the other examples, we have to figure out where each of these goes. So while we're going to get the same measurements here, the order is different. Here along the x-axis, we end up getting 1/2, and that's because the 30-degree angle is at the top, so across from that is going to give us 1/2. Across from the 60-degree angle is going to be our root 3 over 2. So now we end up getting an ordered pair of 1/2, because that's our x value, comma, root 3 over 2 because that's our y value. Now, we need a trick to remember these, especially knowing the difference between which one do we start with when we're dealing with a denominator of 6 versus what do we start with when we're dealing with a denominator of 3. So here's the trick. Focus on just the x value here. What you want to remember is that root 3 over 2 is going to go first when your denominator is 6, and the way I remember that is that 3 times 2 is 6. For the next example, when we're dealing with a denominator of 4, that's going to start with root 2 over 2. And you can either remember that 2 plus 2 is 4, or you can do 2 times 2 is 4. And then finally with the last one, to remember that denominators of 3 will always start with 1/2, just remember that 1 plus 2 gives you 3. If we go back to our radian values on the unit circle and we start to think about all the ordered pairs, when we fill in all of the different wrapping values, again, we have 1, 0 over on the right side. At the top, we go over 0 and up 1. Over on the left side, we're going backwards 1. Down at the bottom, we're going to go to 0, -1. Now, when we start to fill in each of these different measurements, again, we needed to know how far over and how far up we go. So that's why in that previous part, we always used the hypotenuse of 1 because that's the only part we knew. We didn't know until we figured out what the distance across and up would be for each of these different values here. So now that's what we're going to look at. So we said that with denominators of 4, it's always going to be root 2 over 2, comma root 2 over 2. That will always be the wrapping value. The thing that we're going to have to pay attention to, though, is the position of it. So if it's in the first quadrant, both values will be positive. We're going to go in the positive direction for the first value and the positive direction for the second value. Now, when we're moving on to 3 pi over 4, I do know that it's going to be root 2 over 2, comma root 2 over 2, but we have to know what the signs are going to be. And you can think about it either as moving backwards, which is going to be in the negative direction, root 2 over 2, and then up, root 2 over 2, or we just remember that in quadrant 2, all signs would be negative and then positive. Now the same thing is going to be true when we move on to quadrant 3. We've got 5 pi over 4 here. We know that both signs should be negative, and again, that's because we're moving in the negative direction along the x-axis and the negative direction along the y-axis. And then finally for quadrant 4, once again, we know that 7 pi over 4 is going to have a wrapping value of root 2 over 2, root 2 over 2, and then based on the fact that it's in quadrant 4, it's going to be a positive first and a negative value second. Now the same thing continues to happen as I fill in the rest of these. So if I look at pi over 6, again, that trick was that if we start with the denominator of 6, the ordered pair has to start with root 3 over 2. We remember that because 3 times 2 is 6. And they're both going to be positive there. Now over on this side, it's going to still be root 3 over 2, comma 1/2, but this is the negative positive region. So our first value is going to be negative and our second value is positive. We keep going. In the next region, I get a negative root 3 over 2 and a negative 1/2. And then finally for 11 pi over 6, we're at positive and then negative. So positive root 3 over 2, comma negative 1/2. Now finally we fill in the denominators of 3. So once again, they're going to start with 1/2. It's the same exact ordered pair that we get with the 6's. It's just that the numbers are reversed because they came from the same triangle. So here we've got 1/2, comma root 3 over 2. Both values are positive. In quadrant 2, same numbers, 1/2, comma root 3 over 2, but here the x value is negative. In quadrant 3, for 4 pi over 3, we end up getting negative 1/2, comma negative root 3 over 2. Again, both signs are negative. And then finally for quadrant 4, we've got 1/2, comma negative root 3 over 2. Again, because the quadrant 4 is going to be positive for our x value and negative for our y value. So just reviewing really quick again, quadrant 1, all values in the ordered pair should be positive, positive. For quadrant 2, the values that end up in this quadrant should all be negative, then positive. For quadrant 3, all values are negative, negative. And then finally for quadrant 4, all values should be positive and then negative. So here are some examples. Now my advice would be that you pause the video at this point, try each of these examples, and then we'll end up talking about them as you check your answers. Okay, so for pi over 6, when we see a denominator of 6, we have to know right away that it's going to start with root 3 over 2. And if it starts with root 3 over 2, it's going to end with 1/2. Now we also want to think about which quadrant this falls into. So pi is going to mean that we're going to fall in the first quadrant, pi over 6. So both values would be positive. For number 2, as soon as we see that denominator of 4, we need to think of root 2 over 2 comma root 2 over 2. But we also need to consider where that's going to fall in the unit circle, which quadrant. And because our numerator is 1 less than the denominator, it's going to fall in quadrant 2, which means it's then going to be negative positive. For number 3, 3 pi over 2. Now you'll notice the denominators of 2 do not fall in a quadrant. They are on the y-axis. So when we're looking at that, 3 pi over 2 is at the bottom of the unit circle. Therefore, to get to that position, we're at 0 comma negative 1. For number 4, 2 pi over 3, this value is going to start with 1/2, and it's going to end with root 3 over 2. And as far as the quadrant, the numerator is 1 smaller than the denominator, which puts it in the second quadrant. So that value is going to be negative 1/2 comma root 3 over 2. For number 5, again, we see a denominator of 3, which means it's going to start with 1/2 and be followed by root 3 over 2. Now because 5 is 1 less than twice the denominator, again 3 times 2 is 6, minus 1 is 5, that's going to tell me that my signs are positive and then negative. So this exact value, positive 1/2 comma negative root 3 over 2, is what you should end up with. For number 6, with a denominator of 6, we should be starting with root 3 over 2 and ending with 1/2. Again, we look at the rule here, 11 pi over 6. If I did 6 times 2, I'd get 12. Minus 1 would give me 11. So if we're looking at 11 pi over 6, we're in the fourth quadrant, meaning that again, it's positive and then negative. For 5 pi over 4, we see that 4, automatically it should have been root 2 over 2, root 2 over 2. And since 5 is just 1 bigger than the denominator, we know we're in quadrant 3, which means that both signs should be negative. For number 8, 0 is on the right side of the unit circle. So that value is going to be at 1 comma 0. For number 9, again, as soon as we see that denominator of 6, we should be thinking of root 3 over 2. So the ordered pair would be root 3 over 2 comma 1/2. From there, we need to think about the signs. Since this numerator is 1 smaller than the denominator, it is in quadrant 2, which means that the ordered pair will then be negative and then positive. For pi, pi is on the left side of the unit circle along the x-axis, so that value is going to be at negative 1 comma 0. For number 11, as soon as we see the denominator of 3, it should start with 1/2 and then end with root 3 over 2. Here the relationship is that the numerator is 1 bigger than the denominator, which means that both values will be negative. And finally, for number 12, as soon as we see the denominator of 4, we should be thinking root 2 over 2 comma root 2 over 2. The relationship here is that the numerator is 1 less than twice. 4 times 2 is 8, minus 1 is 7. And that means that the ordered pair will be positive and then negative. So we get positive root 2 over 2 comma negative root 2 over 2. Now just again, a reminder, if we look at each of the problems that have a denominator of 3, we'll see that every single one of them starts with 1/2. If we look at all of the ones that have a denominator of 4, every single problem that has a denominator of 4 has to start with root 2 over 2. And in fact, they're both going to be root 2 over 2. We look at the 6's. We want to make sure, and this is what I would encourage you to do when you're doing assignments, is that as soon as we see that denominator of 6, every single one of them better to start with root 3 over 2. Now, other than that, if it has a denominator of 2, it's going to start with a 0. And what we want to remember on ones like number 8 is that that one doesn't have a denominator written. So you want to think about what you would use for a denominator if we don't have one included there. And hopefully you're thinking 1, and that would be correct. So 0 divided by 1 would still just be written as 0. So you can remember that if the denominator is 1, it's going to start with a 1, either a positive or a negative 1. Same thing happens in number 10. Here the denominator would be 1, so it's going to start with a 1. And again, in that case, it ends up being a negative 1. Now, same thing, we're looking at the exact same problems. Just to review the signs though really quick, if we're talking about the first quadrant, all of those have numerators that are just pi, and these are only for the ones that have a denominator of either 6, 3, or 4. So we can see pi over 6, and that's why it's both positives. When I move on to this one right here, negative positive, that's when our numerator is 1 smaller than the denominator. So we see that happening in question number 2. We also see it happening in question number 4. And we also see it in number 9. For our next quadrant, we're looking at the numerator is 1 more than the denominator. And again, this is only for denominators of 3, 4, and 6. So we are going to see that here in number 7, 5 pi over 4, and that's why both of those better be negative. We're also going to see it in number 11, which again is why these are both going to end up being negatives. And then finally in quadrant 4, the numerator is 1 less than twice. So we see that in a couple of positions. We see that in number 5. We also see it in 6. And then finally we see it in 12. Now the examples that I did not circle here, 3, 8, and 10, are because they actually fall on one of the axes. So for those, we don't really think about the signs as far as which quadrant they're in because they're not in a quadrant. So we instead just think about which position they're going to be at on the unit circle. So whether we're moving in the positive direction 1, 0, in the negative direction 1, 0, up would be 0, 1, and down would be 0, negative 1.